So today we have the solution. This is the topic from the class 3rd standard. Okay. So now my first question is, what do you mean by solutions? Right? Okay. So you can answer. So what your answer may be different from the what I want to share with you. Now here solution. So we know solution is the mixture. What type of mixture? That is the homogeneous mixture. Homogeneous mixture of two or more components. So components are representing the different substances. Okay. Now component means term. This is the term which represent the substance. Now here solution. Are the homogeneous mixture of two or more components. Okay, understand? So what do you mean by a homogeneous mixture? Those mixture which shows a single phases. But when you look at, so it's look like a single one. Say for example, you have the water. Okay, as you know the water is transparent, colorless, tasteless. But when you add salt, you know the in our kitchen we have the kitchen salt. When you add the salt, so this salt after dissolved in the water, so it's look like the water, but that is not a pure water. That is the mixture of the water and the salt, but it shows like a single phase. This types of the mixture we call a homogeneous mixture. So now here in the solutions containing the two components only, I mean the solution containing only two components, that mixture what we call the binary mixture. Binary mixture means mixture containing the two components here, right? Okay, two components. I said the two components. Yes, remember two components. Components means the substance here. Okay, so the binary mixture containing the two components. So this is the two component system. Now here in our mixture, one of the components containing the smaller proportion and one of the components containing the larger proportion. So the component, I write the component. So containing the smaller proportion, I mean the lesser amount, smaller proportion. These components we term as solute, right? Solute is the term which represents the components containing the smaller proportion. That components we term as the solute. Then another component, since we are talking about a two component system, another component, so that component containing the larger proportion compared to the amount present, the amount of the solute present. So this component containing the larger proportion, that component we term, I said the term, that is the solvent, right? So solvent is the term which represents the components present in the larger proportion. So these two important terms we remember. Okay, don't confuse. Now here, very important thing is in our solution, that is how much amount of the solute present in our solution. So that amount of the solute present in our solution we express in terms of the strength. In terms of the strength of the solution. So please don't confuse, okay? So what do you mean by strength of the solution? Instead, in the place of the strength of the solution, we sometimes use as the concentration of the solution. concentration of the solution. See in our lower classes, I mean at the time of the class 9, at the time of the class 10, even in the class 8, okay. So your teacher explained about the concentration of the solution. So what are the concentration of the solution? We express it as dilute and concentrated solution, okay, saturated solution, unsaturated solution we learned, okay, at the time of the lower classes. Now, so here, as you know, the dilute, okay, the dilute solution means, okay, larger proportion of the solvent compared to the amount of the solid present. Concentrated solution means, okay, concentrated solution means the larger amount, I mean the larger amount, okay, present in the, okay, given volume of the solution. And saturated solution means what you add the amount of the solute present, so it does not dissolve further when you add more. That is the saturated solution. So it all be learned at the time of the lower classes. Now here, strength of the solution, concentration of the solution, what it does mean. So that is the very important we understand. So the strength of the solution or concentration of the solution, that it means, so it can be it can be expressed in terms of the amount. So it can write in terms of the mass, in terms of the number of, okay, moles of solute, okay, present in the given mass of solvent or volume of the solution. So these types of the expression we call strength of the solution or concentration of the solution. Here, so the amount of the solutes present, if this amount is very high, that is more concentration. If the amount of the solute present less, that is the less concentration. That is the very common sense you know well. Now here, this concentration or strength of the solution we express in different terms. Okay, what are the different terms we express the concentration of the solution? Number one, sometimes we express mass percentage, okay, that is, okay, mass by mass. So in short we write, okay, W by W. So that is we express in percentage. So what do you mean by the mass percentage of our concentration of the solution? So the mass percentage of the solution, it means that, okay, the mass of the solute, what is present in grams divided by, okay, that means mass of the solute present, the amount of the solute present in a gram in, okay, 100 grams of the solution. One thing you please remember here, okay, solution means the, okay, mixture of the two components. One is the solute, another is the solvent. Here, so solution, this is the mass of the solution. What is the mass of the solution in the mass percentage? That is the 100 grams should be. Please remember. So mass of solution, so is the mass of solute plus mass of the solvent, right? So now here, if you know the mass of the solute, if you know the mass of the solution, so we can calculate the mass of the solvent in this case relation. So that's the very important. Sometimes we require the mass of the solvent in other cases. So one of the things you please remember this one, right? So number two is, okay, volume percentage. That is, sometimes we write mass by volume. Okay. Now here, that is, we write W by V. So now what do you mean by this volume percentage or mass by volume percentage? That is the mass of the solute, mass of the solute. This mass of the solute we write in the gram, we calculate in the gram in, okay, what the volume, that is the volume of the solution. What is the volume of the solution here also? 100 ml. Now here, that's the very important to remember that volume of the solution. Sometimes if the volume of the solution is given, say volume of the solution is less than 100 ml. So the volume of the solution is given, it will be multiplied by the 100, that becomes the okay, volume percentage. Now here, one thing, if we don't have the volume of the solution, okay, if we know the mass of the solution, how do we calculate the volume of the solution? We require a 3 parameter. One is volume, right? Another is mass, and the third parameter is K, density. Okay, so what is the relation between these 3 parameters? As you know, that means, okay, we do calculate density. We do calculate density is equal to mass by volume, right? If you know the density of the solution, if you know the mass of the solution, we can calculate the volume of the solution. How do we calculate? Volume of the solution is equal to mass divided by what? Density, right? So in this way we can calculate volume of the solution. If you know the mass of the solution, if you know the density of the solution, okay, right? Then now, so this is the okay, volume percentage, I mean the mass by volume, okay, this express the concentration of the solution. Now next we have the very important is, that is molarity. So it's represented by the capital M. So if I asking you what do you mean by molarity, so it can answer in a very simple way, that is the concentration of the solution. So if I asking to you what do you mean by molarity, so molarity is the concentration of the solution. So how do we express the molarity? So molarity of the solution, that is number of what? Moles of solute. So now here the amount of the solute we express in terms of the mole, number of the moles of the solute present in the okay given volume. What is the volume of the solution? When we do calculate the molarity, the volume of the solution, it must be 1 liter. Remember. So the number of the moles of the solute present in the 1 liter of the solution, that is what we call the molarity of the solution. Now I remember one thing here. So molarity. So what do you mean by 1 molar solution? 1 molar means 1 molarity solution. So 1 molar solution means the number of the moles of the solute here. What is the number of the moles of solute in 1 molar solution? That is 1 mole of the solute. Now here the 1 molar solution, it means that number of the moles of the solute, how much should be? 1 mole. So what will be the volume of the solution? It always speaks in the 1 liter, that is 1 liter of the solution. So 1 molar solution means, what it does means, 1 mole of the solute present in 1 liter of the solution. That is what we call 1 molar solution here. Then now, when we have the number of the moles, so how do we calculate the number of the moles from the relevant parameters? So when we are talking about the number of moles, for any substance, when we do calculate, from what parameters number of the moles can be calculated? So one of the very simplest way, that is the mass of the solute. This mass of solute we used to calculate in the gram. Okay. So if you know the mass of solute in grams, so we can calculate the number of the moles. So this is for the substance. What substance we have? Okay, in our chemistry we have two substances. One is, okay, that is we have the elements, right? Another is the compound. Okay, so now if the substance is the simple elements, okay, so that number of the moles when we do calculate, if you know the mass of the solute, so if the substance is the element, so that's elements, we know that their molar mass. What is the molar mass? What is the molar mass? Yes, you know well what is the molar mass. This is the mass, remember, of 1 mole of substance. Okay, 1 mole of substance. Now here, if suppose the substance is element, this molar mass we also call the atomic mass, right? So let me take an example here. Suppose this element is sodium metal. That is sodium metal. Okay. So sodium metal. What is the atomic mass of the sodium metal? What is atomic mass of sodium metal? That is approximately 23 gram. Okay. That is not only 23 gram. That is the 23 gram in 1 mole. That's what we write per mole, right? So this 23 gram per mole of the sodium atom, that is what sometimes we call atomic mass. That also we consider as the molar mass of the sodium. But in the case of the compound, right? Okay, this molar mass, I mean the mass of 1 mole of the substance, that substance, if we have the compound, that molar mass we also call molecular mass. How do we calculate the molecular mass of the compound? That is the sum of the atomic masses present in the compound. Atomic masses of the element present in the compound. Say, for example, compound is sodium chloride. So sodium chloride is not an atom, is not an element. Sodium chloride is the compound. How do we calculate the molecular mass of the sodium chloride? If I say the molecular mass, you just think it as a molar mass of sodium chloride. How do we calculate the molecular mass of the sodium chloride? If we know the atomic mass of the sodium, what is the atomic mass of sodium? 23, right? So 23. So how many sodium atoms here? 1. So we write this 23 only plus. Another element is the chlorine. So what is the atomic mass of the chlorine? So we know, we remember that we can have, that is 35.5. Now when we do plus, what will be the answer? That is, okay, that is I think 58.5. So this 58.5, what is the unit? So we can express it in the beginning what we write, that is the atomic mass unit. Okay, that I write in U. So this atomic mass unit we converted, we express in terms of the gram. So in terms of the gram means in terms of the molar mass. So how do we write? 58.5 grams per mole. This is the molar mass of the sodium chloride. That means molecular mass of the sodium chloride. Now here, if you know the mass of the solute, whether it may be the element or maybe the compound, mass of the solute is given here. So we can calculate the number of the moles of the given substances if we can calculate the molecular or molar mass of the substance. So remember this one. Then the number 4, what is the concentration of the solution? Now I write the number 4, that is the molarity. I write a small m. So molarity, what it does mean? So molarity is also one of the concentration of the solution. In short, we can say molarity means concentration, terms or unit. Now, what do you mean by the molarity? Here, molarity also, that is the number of the solute, a number of moles of solute present in. Now, what's the difference? What's the difference between the previous one? What is the difference between the molarity and molarity? The simple difference is, in the case of the molarity, okay, the number of the moles of solute is present in the volume of the solution. But in the case of the molarity, that's not volume of the solution. Here is the mass of solvent. How much mass of the solvent we calculate molarity? That must be 1 kg. 1 kg of the solvent. Here, so now here, this number of the moles of the solute is common in both molarity and molarity. But only the difference is, okay, in the case of the molarity, that was the volume of the solution. Now in the case of the molarity, only the mass of the solvent here. How much mass of the solvent should be there? 1 kg. That is the difference. So if somebody asking to you, what is the difference between the molarity and molarity? That is the difference only. Now here, this mass of the solvent, if you know the mass of the solution, as I already given to you, mass of the solution, if you know the mass of the solution, so if you know the mass of the solute, so can we calculate the mass of the solvent? That's the relation I given here, mass of the solvent. So this is the relation. See, mass of the solution is given, mass of the solute is given. So how do we calculate mass of the solvent? That means mass of the solution is the sum of the mass of the solute plus mass of the solvent. Right. So if you know this, we can calculate this point K, where we can use it. Right. Now here. So similarly, when I discussing about a molarity, just I was talking about a 1 molar solution. 1 molar solution. Now similarly, I asking you 1 molar solution. Yes, I think you could answer because you already learned how do we answer 1 molar solution. Similarly also 1 molar solution, what it does mean? Now here, number of the moles of the solute here in 1 molar solution, that is the 1 mole. Right? 1 mole of the solutes present in, okay? So now here is the mass of solvent. How much mass of the solvent in? How much? 1 kg of the solvent. 1 kg of solvent. So that solution what we call 1 molar solution. Right? So I think you understand about the difference between the 1 molar solution and 1 molar solution. Sometimes anyone can asking you what do you mean by 1 molar solution and 1 molar solution. Here, very important, okay. So idea we can put up here. See, 1 molar solution and 1 molar solution. See, some similarity is here. One similarity is here. Here both the solutions containing equal number of moles of the solute. How much mole of the solute? 1 mole of solute. Right? So, what is the difference between the 1 molar solution and 1 molar solution? In 1 molar solution, that is the 1 liter of solution. 1 liter of solution in 1 molar solution. But in 1 molar solution, what is the K amount of the solvent? That is 1 kg solvent. Now, when we do prepare the 1 molar solution, when we do prepare the 1 molar solution, my big question is, which one is the more concentration? That is the very big question. See, I repeated once again, 1 molar solution and 1 molar solution. So what is the similarity? What is the common thing is here? The common thing is here 1 mole of solute. Here also 1 mole of solute. Here also 1 mole of solute. Only the difference is in 1 molar solution, here is the 1 liter of solution. But in 1 molar solution, what is it? 1 kg of solvent. Now solution as you know, that is the solute plus solvent. So now here the plus of this solute and solvent, that would be 1. That means sum of the values is in the 1. That means solvent is not totally 1 liter. right? Because the solution is the solution is the sum of the solute and the solvent. The answer will be the 1 liter. That means 1 liter means that is the sum of the solute and the solvent. That means the amount of the solvent is less than 1, right? But in the case of the 1 molar solution, that is solution only the 1 kg, pure 1 kg. Here is the 1 kg solvent, here is less than 1 liter of the solvent. Though this solvent and this solvent is same. Suppose this solvent is also water, this solvent is also water. So 1 liter of the water, 1 kg of this water, both are the same amount. But in the solution, 1 liter of the solution is not a 1 liter of the solvent. Therefore, so 1 molar solution, more solvent is there. In 1 molar solution, less solvent is there. Therefore, 1 molar solution, it's more concentrated. It's more concentrated. Concentrated means, more concentrated means, though the number of the moles of the solute is same, since the amount of the solvent is less, therefore the number of the moles of the solute is more in the 1 molar solution than the 1 molar solution. Therefore, 1 molar solution is more concentrated than which one? 1 molar solution. So, remember these things. Very important. Next. Number 5. I think number 5, no? Number 5. There is normality. Normality. So when I asking to you, what do you mean by normality? Simple answer as before. This is the concentration of the solution. In short, this is the concentration term, right? How do we define the normality? So we define A. This is the number. Instead the number of the moles. So we write, in the case of the normality, we write A. Number of gram equivalent of solute divided by, that means number of the gram equivalent of solute present in, here is 1 volume of the solution, here also the volume of solution, 1 liter. See, now we have some similarity with the previous concentration term. One of the similarity is that molarity. Here molarity. In the case of the molarity, that was also volume of solution 1 liter. Now in the case of the normality also, what is similarity? Here also volume of the solution 1 liter. Only the difference is, in the case of the molarity, that was the number of the moles. But in the case of the normality, what is it? Number of the gram equivalent of the solute. Now at that time we already just discussed how do we calculate the number of the moles from the given masses. Now here that same question here. Now how do we calculate the number of the gram equivalent of the solute? Now I write the number of gram equivalent. Gram equivalent. Here the similarity is that at that times number of the moles of the solute, number of the moles when we calculate, we require the mass of the solute. That means we require the mass of any substance given. Okay? So when we do the calculate the number of the gram equivalent of the given substance, we require mass of the given substance in the gram. That was also same with the number of the moles. That time also mass of this substance in the gram. But here only the difference is, in the case of the number of the moles when we do calculate, that was the mass of the substance divided by molar mass. But in the case of the gram equivalent, this mass of the substance in gram will be divided by equivalent mass. Equivalent mass of the substance. See, what is the difference between the molar mass and equivalent mass? See, remember, very easy to understand here. Equivalent mass, suppose the substance is metal. metal, I just write sodium metal when we talking about a sodium metal. See, what was the molar mass of the sodium metal? I think you remember still, right? What is the molar mass or atomic mass of the sodium? That was 23 gram. Okay, so this is the metal. Okay, what is the valency of the sodium metal? That is the valency of the sodium metal is 1. So if the substance is the metal, right, how do we calculate the equivalent mass of the given metal? So it's very easy. So equivalent mass equal to molar mass divided by their valency. What is the valency of the sodium? 1. So that we will divide it by 1. That is equivalent mass of the sodium is equal to the molar mass of the sodium, right? Now, but in some cases, let me take the example, that is the H2SO4. This is the sulfuric acid. Now, this is the compound. Understand? This is the compound. So now, when we do the molecular mass of this sulfuric acid, how do we calculate molecular mass of the sulfuric acid? So, one is the atomic mass of the hydrogen is 1, right? How many hydrogen atoms here? 2. That multiply by 2 plus. What is the atomic mass of the sulfur? That is the 32 plus. How many sulfur here? 1. I write only 32. Then another one is oxygen. What is the atomic mass of the oxygen? 16. Multiply by how many oxygen here? 4. So when we do multiply and plus, so it could find 98 grams per mole. So if you know the molecular mass or molar mass of the sulfuric acid, right? Okay? This side, right? When we do calculate the molecular mass of the sulfuric acid is the 98 grams per mole. So this molecular mass of the sulfuric acid and equivalent mass of the sulfuric acid may be same or may be different. Let me calculate. So how do we calculate? But in the case of the metals, we need to know that what are the valency of them. But in the case of the acid, this is the acid. You know sulfuric acid. The name also we say sulfuric acid. Now acid. You know acid is related to the hydrogen ion, right? Now in the sulfuric acid, how many hydrogen ions are there? There are 2 hydrogen ions. These 2 hydrogen ions can be replaceable. So the number of hydrogen ions replaceable, that is 2 in the case of the sulfuric acid. So when we do calculate the equivalent mass of the acid, so how do we calculate? So molecular mass means the molar mass of the acids given divided by number of the hydrogen ion replaceable. In the case of the sulfuric acid, that will be the 2. What is the molecular mass of the sulfuric acid? That is the 98. And divided by number of the hydrogen replaceable, that is the 2. We'll divide it here. How much will be here? So how much will be here? That is, okay, how much? 98. 98 divided by 2, that is 2. How much? It should be 4 and it should be I. That means 40. Now, it should be 9, right? That means 49 is the equivalent mass of the sulfuric acid. 98 is the equivalent mass or molecular mass of the sulfuric acid. So, if the number of the hydrogen ion replaceable, this number of the hydrogen ion replaceable, we generally call basicity. Okay? If the basicity is the 1, of 1, for that given acid, the equivalent mass and the molecular mass will be same, right? If the basicity is more than 1, I mean not 1, that means maybe 2, maybe 3, maybe 4. So their equivalent mass is different from their molecular mass. If basicity is the 2, the equivalent mass is the half of the molecular mass. If the basicity is the 3, that is the 1/3 of their molecular masses. Okay, to remember it. So this is the way how do we calculate the equivalent mass. Now here, so when we are talking about the normality, as similarly we talking about the molarity and molarity. Now here I write one normal solution. one normal solution. So sometimes we write a one normal solution, we write like this, but sometimes we write 1n. So some of the students confuse what is the 1n. So it can be interpreted in different language. It may not be one normal. Okay, so some of the students confuse what do you mean by 1n. In our chemistry, 1n means one normal solution. Right. What do you mean by one normal solution? Similarly, remember the definition. One normal solution means number of the gram equivalent of the solute means 1 gram equivalent. 1 gram equivalent of the solutes given here present in what is the volume of the solution? That is 1 liter of the solution. These types of the solution we call one normal solution. Now, very interesting one thing. See here, the volume of the solution in the normal solution, one normal solution, 1 liter solution. In the case of the 1 molar solution, that volume of the solution is also 1 liter solution, but only the difference is 1 gram equivalent. So in the 1 molar solution, 1 mole of solute. So some of these solutes, the number of the moles and the number of the gram equivalent, sometimes the sum of the solute are same. If the number of the moles and the number of the gram equivalent same, so the concentration of the 1 molar solution and 1 normal solution is same. But if the number of the moles of the solute when we do calculate and the number of the gram equivalent when do we calculate different, so concentration between these two will also be different. Don't forget, right? So this is about the normal case solution. Now here, so far what we are discussing about these things. See, our concentration term. What the concentration terms we are talking about, I repeat it again. One is mass percentage. Number 2, volume percentage. Number 3, we are talking about the molarity. Then number 4, we are talking about the molarity. Right? Number 5, we are talking about the normality. Okay? So now here, what we are discussing about these things here, so some are very common. What are common in these cases? What are common? So one of the common thing is that is the mass of solid. This mass of the solid is common, right? Okay, but in some cases, say like mass percentage. Here the mass percentage, in this case, that is present here, that is the mass of solution. Volume percentage, in this case, what is there? That is the volume of the solution. Here, volume of solution. Molarity also, number of the moles, mass of the solid also there, number of the moles is there, right? But in the case about the solution, that is the volume of the solution. In the case of the molarity, we don't have any relation between the volume of the solution. Here is the mass of the solvent. Mass of solvent. But in the case of the normality, here is the what the important is, that is the volume of solution. Now, my important point is, what is the role of this volume of the solution? Remember, I write very clearly, volume of solution is the function of temperature. Is the function of what? Is the function of what? Temperature, right? That means, what it does mean. So, when the temperature increase, right? When the temperature increase, and definitely volume also will increase, right? Understand? When the volume change, okay, the concentration related to the volume of solution, the concentration of the solution related to the volume of the solution are also changing, right? See, I repeated once again. If the volume of the solution changes, the concentration terms, what are the concentration terms, okay, which are related to the volume of the solution? Number 1, volume percentage. Number 2, molarity. Number 3, normality. These are related to the volume of the solution, right? So, temperature change, volume change. When volume change, this concentration also will change. But remember, these concentrations are reciprocal to the volume of the solution. I repeat it again, this concentration of the solution are reciprocal to the volume of the solution. When the volume change, this concentration will change. What changing? That should we understand. What changing? When volume increase, this concentration will be decreased. Remember, I repeat it again. When volume increase, this concentration, what I mean, this concentration which are related to the volume of the solution, okay, this volume percentage, this molarity, this normality, so this concentration will be decreases, right? Then when temperature increase, volume increase, right? Their concentration will be decreased. So one question, just let me ask you, which of these concentration terms, temperature is depending, right? Number 1, volume percentage, it depends. Number 2, molarity, it depends temperature, and normality depends. Now here I choose these 4. One of the concentration, molarity, so this concentration term is independent on temperature. No effect. When we change the temperature, whenever we change the temperature may be just decrease or increase. So there is no any effect on the molarity. Because why? Because there is no any function of the volume of solution. There is only the function of the mass of the solvent. So this mass of the solvent does not affect it when the temperature increases. So these are the important concentration terms. So lastly, finally, let me share with the one of the very important concentration term is mole fraction. Mole fraction. See, what do you mean by mole fraction? Yes, I think mole fraction means some fractions of the moles, out of the total number of the moles. Suppose the total number of the moles is 100. This total moles of the mole is the sum of the moles of the different components. If suppose the components containing, the solution containing 2 components, the total number of the moles is 100. One of the components containing the 90%, that means 90 gram. What is the remaining amount is the 10. That 10 or 90 is the fraction of the mole of the components present in. So that is what we call mole fraction. So in short, mole fraction. Suppose when we have the solution, what the solution containing, that is a 2-component system. I write binary mixture. In the binary mixture, that means containing 2 components. So what a component, I just write here component A and component B. So what are the A and B? A and B are the components, right? So now here, when we do the calculation of the mole fraction of the A, how do we calculate mole fraction? I write x, small x. Small x is the mole fraction. So when we do the calculation of the mole fraction of the A, what is the mole fraction of the A? So that means number of the moles. I write number of moles. Moles of the component A. So let me write n is the number of the moles of the component A, I write Na, divided by total number of the moles of the component A and B. That means number of the moles of the component A plus number of the moles of the component B, and B is the number of the moles of the component B, right? Okay, so this is the total number of the moles of the our binary mixture. How much a fraction of the moles present in our total moles of the our solution, that is what we call the mole fraction. So when we do the calculation of the mole fraction of the A, that is I write Na divided by Na plus Nb. If you know how to we calculate the mole fraction of the component A, so can we calculate the mole fraction of the B? It's very simple. That is number of the moles of the component B divided by total number of the moles of the A plus number of the moles of the component B. That's the very simple. But in the simplest way, how do we calculate? For the binary mixture, if we do calculate one of the mole fraction of the component A, so we don't need to calculate the mole fraction of the component B for using this formula, because mole fraction, the sum of the mole fractions, if suppose we have a 2, that is XA plus XB, is always equal to 1, not only binary mixture. Okay, so number of the components may be there. I component, suppose I write component 1, component 2, component 3, then component up to the I component. When we edit all these mole fractions, the answer is always 1. So this is the way how do we calculate. Therefore, what I said, for the two component system for binary mixture, if we calculate the mole fraction of the one component using this formula, we don't need to use this one, because we know XA plus XB is equal to 1. This is the way how do we calculate, right? So remember, this is the mole fractions of the hour. Now here, in the very simplest case here, when we do the calculation of the mole fraction, by the way, what we remember, that is mole fraction of the A is equal to Na divided by Na plus, what is it? Nb for the component, two components, right? Then now here, one of the, suppose I just take a very simple example here. Simple example, what I mean that, okay? So what is the number of the moles of the Na? How do we calculate Na? If you know the mass of the component A, mass, I write Wa divided by molecular mass of the component A. This was the formula we used last time. Similarly, when we do the calculate number of the moles of the B, how do we calculate? Weight of the B is given divided by molecular mass or molar mass of the component B. Now here, just I pointed out at last moment here, for the future, how do we calculate? 1 kg of water. 1 kg of water. What is the number of the moles of the water? What is the number of the moles of the water? I asked you, right? So how do we calculate? So I think 1 kg of water. 1 kg. So though they give it 1 kg, but we need to calculate in the gram, because molecular mass of the water. What is the molecular mass of the water? Yes, you know it. That is, 1 is the atomic mass of the hydrogen multiplied by 2. That is the number of the hydrogen. So plus, what is the atomic mass of the oxygen? That was 16. 16 plus 2, that is 18. Now here, what is the unit of this molecular mass of the water? That is gram per mole. Remember. Now here the unit of this molar mass is gram. So if we do calculate in 1 kg, the calculation will be wrong. Therefore, the mass of the water, it should be in gram. Therefore, 1 kg we have to convert it into gram. That is 1000 gram of the water, right? For 1000 gram of the water, what is the number of the moles of the water? That is divided by 18 grams per mole. So, unit, we have to see the unit. When we cut it at some common units, the units remain there is a correct for the number of the moles. If the units correct, the calculation is also correct. So you have to verify similarly. So when we do the 1000 divided by 8, that is 55.5, something is here. So this is the number of the moles of water in 1 kg, right? So don't forget, sometimes without calculation, we have to easily remember that what is the number of the moles in 1 kg of water, right? Sometimes 1 kg of water, sometimes we say 1 liter of the water, because the density of the water is 1 gram per centimeter cube. So therefore, 1 liter of the water is same with the 1 kg of the water. Please remember up to this for today's class, right? Okay, so see you then on the next class, okay? Please share with your friends and subscribe for me, right? Okay then.